Hello. For this problem, according to Master Foods, the company that manufactures M&Ms, 12% of peanut M&Ms are brown, 15% yellow, 12% red, 23% blue, and 23% orange, and the last 15% are green. Round all answers 3 places. Compute the probability for each. We're selecting one M&M. Is not orange. When you're talking about the complement that it's not orange, you can take 1 minus the probability it is orange. And so the probability not orange, you take 1 minus the probability it is orange, which was 0.23, and you get 0.77. So when you're doing the complement, it's just 1 minus. The complement means the opposite. So if it was the probability it's not brown, then it would be 1 minus 0.12. Compute the probability that a randomly selected M&M is red or orange. Now when you have an or, you take the probability of the one plus the probability of the other one and then subtract the probability of both of them. So the formula here, the probability of red or orange is the probability of red plus the probability of orange minus the probability of red and orange. Now, that's not a possibility. Red and orange will not overlap. It's either a red M&M or an orange M&M. So in this case, you're subtracting 0. But if there was an overlap, then you're adding it into both of them and you need to subtract 1 out. So if you take the probability of red plus the probability of orange, you'll get 0.35. Compute the probability that 2 randomly selected M&Ms are both blue. Well, the probability of one of them being blue, right here, 0.23, and the probability the second one is blue is 0.23. And so you would multiply those probabilities together. No, they also wrote it as the quantity squared, which is also fine because it's both the same. But it's 0.23 times 0.23. 0.0529. And each one is independent of the other. If they weren't independent of the other, like if you were just using a bag, that's why they're saying the independence. If it was a small bag, then you got to realize if you didn't put it back in, it could change the probability. But when they're using percents with that many items, they're independent. The probability neither is green. That's like the complement here, not orange. The probability it's not green is 1 minus the probability it is green. And then we would have that twice because both of them are not green. So it would be 1 minus 0.15 twice, or quantity squared. The probability at least one is green. Well, at least one means one, first one, second one, or neither. I mean both. So neither would be the only case that's not in there. And that's why you can take 1 minus the probability neither is green, because that would be its complement. And probability neither is green. We did that right here, 1 minus probability green, which then gives us 0.2775. Because we're taking neither one green. 1 minus 0.7225 is 2.775.